Hi everyone, thank you for being here and thank you for giving me this opportunity to present to you my communication. Let me introduce myself. My name is Nisrine Marrakchi and I am a PhD student in the Polydisciplinary Faculty of Marrakech, Morocco. My communication is about Lstm recurrent neural network for daily forecast of PM10 concentrations in Tangier. For this, I will adopt the following plan. After introducing my communication, I'd like to take a look at the artificial neural network in general, which called ANA. Then I will continue by another type of ANA, which are the recurrent neural network RNN, especially the sample RNN and the Lstm architecture. Next, I will talk about machine learning application process, and before concluding, I will describe our experiments and the results obtained. Air pollution is an extremely important threat because the quality of the air has a direct influence on our health and our environment. For that reason, predicting the air pollution levels of the coming day is the crucial step in urban air quality management. So it is necessary to face up these pollution peaks, which is possible by adaptive air quality forecasting. So these predictive models make it possible to follow the atmospheric mechanisms, and they can provide the authorities with the necessary information to take emergency measures in order to reduce these pollution peaks. So this work aims to predict daily PM10 concentrations in the city of Tangier using two algorithms of RNN, a recurrent neural network, which are the simple RNN and the Lstm architecture. As you know, most of the air pollution problems in Tangier are linked to several pollutants, among them PM10, which becomes more concerning. So what is PM10? PM stands for particulate matter, the term for a mixture of solid particles and liquid droplets found in the air. Particulate matter can be inhaled and cause serious health problems because some particles less than 10 micrometers in diameter can get deeply into our lungs and our bloodstream. So, now I will move to another section in which I'm going to talk about artificial neural network, which are a family of statistical models. So a neural network is formed from some of an interconnected nodes known as neurons. This usually organized into layers. So a feed-forward neural network will have at least an input layer, a hidden layer, and an output layer. Now, how the neural network works. Each neuron receives data, processes it in the hidden layer, and provides an output, which becomes the input of the following neurons. After that, we use the gradient descent algorithm to train our networks and update iteratively all parameters in view to reduce the error between target data and our model's output. So now I will continue by another type of ANA, which is RNN. The advantage of this type lies in their ability to take into account the past context when processing current information. As we can see in the equation, there is a term has been added. But however, these networks have limitations because of two problems. Are called vanishing gradient and gradient explosion. So therefore, to overcome these problems, another type of RNN is used, which is the LSTM. Particularity of LSTMs lies in how the hidden states manage, because the processing with LSTM is replaced by a memory cell and some gates. In general, it's a batch of mathematical calculations that have just been applied to some incoming information to finally get an output. Now moving to the next part in which I'm going to talk about machine learning application process, which called also data preparation. So data preparation is the transformation of our data into a form that is more suitable for modeling. Our dataset may contain missing values for various reasons that can impact the result of the model. So there are many ways to handle this problem. In the current study, we have used the k-nearest neighbor. Also, we have used the min-max scalar transform was applied to the PM10 dataset directly to normalize the input variables and scale values to the range 0 and 1. In our time series, there is no concept of input and output features. Instead, we must choose the variable to be predicted and try to construct our input and output that will be used to make prediction for future time steps. And also we have to split our dataset into two bases: training datasets and test datasets. So we noticed that in our case the best percentage for the learning base is 70% for the two models. So our dataset provides the number of daily concentrations of PM10 air pollutants from January 2010 to April 2040. So we start by calculating descriptive statistic of our time series because that can get an idea on the distribution of values. After plotting our dataset, and we can see that during the period studied, it was observed that the concentration of PM10 in Tangier increases until it reaches its peaks, and it decreases after that. So I will describe now our experiments. So firstly, we built both a simple RNN and Lstm model using just pollutant data of PM10. So there are various parameters to settle when creating each of models. So after that, we changed our configuration and we added the other predictors and to observe if that increased the performance. So this process was repeated until the model was good and kept the configuration with the best results. The results of simple RNN and LSTM with different inputs are shown in this table. Each experiment with RNN models was run several times and we gave the average of values of error indices to study the relationship between predictors and performances. So we can see that the performances of the model are enhanced by the addition of the other predictors because it's clear that the end argument has been increased and the error has been decreased. So in general, according to the results, it's evident that the LSTM is slightly better than simple RNN. So now the graphical representation of the predicted and observed values is presented in this figure. As we can see that the LSTM is better because it works very well at peaks level. So in this stage we use the LSTM model in order to forecast the 3 months starting on 1st January 2040. Conclusion: in this study, two types of recurrent neural network, the simple RNN and the LSTM algorithms, were developed for sequential data. So these models were trained with pollution and meteorological data and showed good results. So the results demonstrated that the LSTM techniques performed better than the simple RNN approach. And thank you for your attention.